I think your mic is muted.
Who said that? Who said I think your mic is muted?
Me? I thought my computer was messed up, but it went on too long.
Lewis Thomas, you are a smart cookie. Jack McVee's sitting here with his white dress shirt on, not saying a gosh darn word. Tisk, tisk.
I thought it was just my computer too.
No, man, I'm sorry. I don't know why it was muted. I guess I wasn't paying attention to that. But okay, so what I was saying is that we had a word of prayer, and this is a warm-up question for you guys that's on your screen now. And what I was just about to tell the folks here in class and you guys online now that you can hear me is that tomorrow I'm going to give you a little quiz, okay? And I think I might have mentioned it. Did I mention this on Tuesday? Did I tell you guys this on Tuesday? Okay, sweet. So it'll be a quiz over what we've talked about thus far in this chapter, and you'll want to make sure you practice, simplifying square roots and cube roots and whatnot, adding, subtracting, multiplying, dividing, square roots and cube roots and whatnot. And then now we've learned in section 8.5 about, 8.6 about solving equations, okay? Luke, did your brother get home last night and say he had a good day? Good. I'm glad he did. It was a fun group. Let's take about another 30 seconds or so, see if we can wrap this up. All right. So, Joe, tell me about my first step. What should I do? Very good. I'm going to subtract 5 from both sides. I got square root of y minus 5 equals y minus 5 over on the right. All right. Now, Alex, what should I do next? No. You're reading what I already have on there. I want to know what should I do to both sides. I need to perform an operation to both sides to get rid of that radical. You remember what that operation would be? Since it is a square root. Very good. We're going to square both sides. Now, I kind of had to hand that one to you. I'd rather you guys know it. Remember, when you get the radical by itself, that's step number 1 of our little 4-step process. Then when you have the radical by itself, if it's a square root, you square both sides. If it's a cube root, you cube both sides. If it's a 20th root, you would raise both sides to the 20th power, okay? Whatever you got to do. Now, when I square the left side, Luke, what happens to it? Yeah, very good. The square root and the square undo each other. And we're just left with the, what do we call that thing inside the radical sign there, Paul? Whatever is in the radical sign, we call it the, a little vocab word. Tiago will help you out. The radicand. All right, good, the radicand. So in other words, squaring the square root leaves us with the radicand, okay? So on the right-hand side, Josh, what do I have now? He's not on there. Let's see here. I was going to ask one of my online guys. Who can I hit up? Who can I hit up? Joey. I'll pick on Joey. I thought I could have sworn Tensor was on there. All right, Joey. What do I get on the right hand side, or what kind of process is that? Joey. Joey. All right, Nate, I'll call on you since Joey's MIA. Nate Dogg. People without microphones. You're so 20th century. Zweig, help me out. John Zweig, I know your mic works.
A foil problem?
It is a foil problem. Very good. And at this point, we ought to be able to foil in our heads. You guys agree with that, hopefully, all right? So, Drew Benton, give me that right-hand side. Minus 10y plus 25. Very good. That's y minus 5 times y minus 5. Don't make the rookie mistake of just saying y squared plus 25. That's a swift kick to the gonads. All right? You don't want that. Our next step, now that this is a quadratic equation, Charlie, is to do what? We've only done this about 100 daggum times. How do I find both answers? Set it equal to 0. F word. Fall. Factor! And then use the blank, blank, blank. Luke? The zero product property. All right, good. So we're going to set it equal to 0. You're right about combining like terms. So you got y squared minus 11y plus 30. And then we're going to factor that out. Quentin, factor it out for me, please, sir. Very good. Y minus 5, y minus 6. And therefore, that tells me that y equals 5 or y equals 6. Mossy, why didn't I put a box around those answers and say, we're done? Oh, okay. So like we're already to the point at which we have 2 answers. Well, but why am I not finished with this problem, in other words? Good. I need to check it and make sure that there are not any extraneous solutions. Now, what would an extraneous solution look like? An extraneous solution would be if I plugged it back in and it didn't make a true statement. Plain and simple. Both of these actually work. 5 minus 5 is 0, square root of which is 0. 0 plus 5 on the left gives me 5 on the right. 6 minus 5 is 1, square root of which is 1. 1 plus 5 is 6. 6 on the left, 6 on the right. Both of these are legit good answers, but I can guarantee you that you'll see a radical equation in the not so distant future that has an extraneous solution on it. And if you're not on your toes, if you skip over that 4th step, then you will say something silly like, oh yeah, here are my 2 answers, y equals this or y equals that, and then one of them will be wrong and you'll get points taken off, that kind of thing. Okay, so we don't want to include a wrong question. All right, so anything you want to ask about this section 8.6? I feel like you guys did a real good job on it for me. Anything you want to ask? Tiago, anybody? I thought I saw a hand over there. 6 minus 5 is positive 1. No worries. Anybody else? All right, on we go. To the wild blue yonder. Now, when we talk about radicals, part of the discussion is going to revolve around this notion of functions, right? And so I got 3 more little warm-up questions for you in this next section, okay, that involve sort of our study of functions. The first one is just a simple inequality I want you to solve out. Go ahead and mow through it. We learned about that back in August. And then the second 2 deal with this idea of again, like I said, functions, okay? And especially number 3, you might have to go back in your notes and consider what interval notation is. I'll highlight that for you because that's a phrase that I used a long time ago. You probably hadn't seen it or thought about it in a while, perhaps. So we'll revisit that notion, okay? Interval notation. Come on, OneNote. There you go. There you go. Paste. No. My youngest child has been extra grumpy lately in the mornings, getting up and getting going. Then given my wife, who takes the children to school with her, because she teaches at their school, has been giving her lots of trouble. And so I thought, I'm going to pull the dad move this morning. I'm going to get her up super early, and she and I are going to have some bonding time. So we did. We got up early. I made a ham and cheese omelet and some waffles. And we sat down together at the breakfast table and we ate breakfast and just chit-chatted. And then we read her favorite book, Dragons Love Tacos. Y'all ever read Dragons Love Tacos? Oh yeah, Drew Benton knows what I'm talking about. The dragons, if they love tacos, but if the tacos have spicy peppers in them, then it disagrees with the dragon's system, and he starts breathing fire. Smoke comes out of his ears, and he'll breathe fire. And so they have a taco party. They ordered tacos from the taco cave, and they had a taco party, and some idiot accidentally slipped some spicy peppers in their tacos, and so they burned the whole house down. It's hilarious. It's a great book. So anyway, we had a good morning together, Jenny and I did, and really started the day off on a good note. I thought, you know what? Hashtag dad win. You guys ever get up early and eat you a nice hearty breakfast? Or are y'all like, James, what's your go-to breakfast move? A breakfast essential, okay. Mrs. Morgan actually bought some of those the other day. I don't know what brand she bought, but she bought some because my kids, I don't know if you guys are like this, my kids usually, at least the older two, they like to grab something out the door and eat it in the van on the way to school. Like they'll get a Pop-Tart or a granola bar or something like that. And I'm just like, no, I can't do that. Can't do that, Jay Coxley. All right, number one. Enough beating around the old bush. Lewis Thomas, what'd you do on number one to get X by itself?
I subtract 1 and divide it by -2.
All right, when you divide it by -2, what'd you end up with?
X is less than or equal to 1/2.
Less than or equal to 1/2. I thought it was greater than or equal to.
You flip the sign when you divide by a negative.
You are correct, sir. Very good. Well said. So you could have done that. You could have added 2x to both sides and divided by 2 and then had the x on the right side, which is a little goofy with inequalities, and just kind of reverse the orientation there, and you still end up with x is less than or equal to 1/2. Good. That's solving basic inequalities. I mean, that's child's play. You probably did that in 7th grade, okay? Number 2 is just a plug and chug, isn't it? Number 2 is just quote, evaluating a function. Remember what we talked about with functions? We said that f of x equals 3x minus 4. By the way, what kind of a function is that? It is a linear function. All right, linear functions. What's the shape of a linear function? A line. You're like, okay. You would be amazed at the number of people that I ask that question to, and they don't know the answer. A linear function. Anyway, y equals mx plus b, you know the whole idea. What's the slope of this linear function? 3. And what's the y-intercept? -4. Okay, good. A little review there. But look, f of x equals 3x minus 4. F of 2 would be 3 times 2 minus 4. F of -1 would be 3 times -1 minus 4. F of 0 would be 3 times 0 minus 4. Okay, so bam, bam, bam. I want 3 answers. We'll go Tiago, Luke, Charlie. F of 2, Tiago, bam, bam, bam. Let's go. You got 2. All right. Luke. Negative. Ooh, I don't know if I like that one. -1 times 3. -3, -4 makes. Can we say -7 instead? All right, Charlie. How about f of 0? -4. All right, fabulous. The way that we get those again is we just let x equal whatever number is in the parentheses. We're plugging and chugging. We are, quote, evaluating. 2 goes in and 2 comes out. Why is that? 2 times 3 is 6. 6 minus 4 is 2. So 2 comes in, 2 comes out. -1 comes in, -7 comes out. And 0 comes in, -4 comes out. If I were to plot those 3 points, right? Again, I'm doing a little bit of review for you guys. But if I were to plot those 2 points, 3 points, excuse me, they would all be what? Oh, use a good geometry vocab word. They would all be, put a prefix in front of it. They would all be collinear. I did a terrible job of planning my graph on that. I don't know why I went so far to the left. But here, we'll do this. The power of one note. Much better. Yeah, those are all 3 collinear. I know my line is not the straightest of lines, but there you go. That's the function f of x graphed out. Now look, I'm making a big fat hairy deal about this in the quote warm-ups, right? Because in just a little bit, we're going to start talking about graphing out the square root function and the cube root function. And we need to remember things like, oh, what comes in is my x value, what comes out is my y value, right? And every ordered pair constitutes a point on the curve, in this case, the line, all right? All right, so now we sort of shift gears. We look down here at this new function, the square root function. We say state the domain. Okay, so Jack, what does the word domain refer to? Is it the set of inputs or the set of outputs?
The set of inputs.
Yeah, it's a set of x values. In other words, what am I allowed to plug into the square root function? What kinds of numbers am I allowed to take the square root of? Honestly? A little bit louder. All right, so anything that's greater than or equal to 0. So x could be greater than or equal to 0. Can I take the square root of 0? Yes. Can I take the square root of 1? Yes. Can I take the square root of 2 and 3 and 4? Yes. Can I take the square root of something like 0.1 and 0.2? Could I take the square root of pi? Could I take the square root of a billion? Yes. Could I take the square root of negative something? No. So we're restricted. Now, as far as interval notation goes, I don't know if you guys remember your interval notation, right? But interval notation would say, all right, for the domain, I start at 0 and I go to infinity. That's our interval notation. Remember the difference between the brackets and the parentheses? You guys remember that at all? Okay, it's been a minute. We use brackets when we want to include that end point, and we use parentheses when we want to exclude or when we cannot include. Like I can't say x equals infinity. It just goes to infinity. All right. So that's the domain. How about the range? What does the range have to do with? If domain is the set of inputs, Paul, range is the set of outputs. That's our y values. Okay. And I don't know if you guys, I feel like we have a pretty solid understanding of inputs, like what we're allowed to take the square root of. What kind of outputs do we get with square root functions? A square root is a non-negative thing. So like, for example, the square root of 1, the square root of 2, the square root of 3, the square root of 4, the square root of 5. All of these are non-negative, okay? The square root of a million, the square root of a billion. Anything I take the square root of is non-negative. Similarly, therefore, the range is from 0 to positive infinity. All right, so our range, to use interval notation, would be exactly the same as our domain in this case. And that's one point to make here with the square root function, is that the domain and the range are both the same. Okay? Now, that being said, let's look at a couple of basic graphs. I know there's a lot of information on the screen right here, and you guys need to soak it all in, write it all down. And some of this you probably already know, okay? Like, for example, the square root of 1 is 1. The square root of 2 is, the square root of 4 is 2. The square root of 9 is 3. You already know that. You already know things like the square root of the cube root of 8 is 2, right? So, like, when you look at these pictures, right, like the square root, these graphs, the square root of 9 is 3. Each point that we put on the curve corresponds with an ordered pair. I just highlighted a couple of them for you. Okay. And the major difference between the square root function and the cube root function is the fact that you can take the cube root of a negative. You cannot take the cube root, the square root of a negative. All right, so like in blue there, look what I highlighted in blue. The point -1, -1. What's the cube root of -1? Well, it's whatever number, when multiplied by itself thrice, that equals -1. And in that case, it's -1. So there's a difference in the domain and range between these two functions. The domain and range are restricted by definition in the square root function, whereas there are no restrictions on the cube root function. These are what I call the, quote, basics, okay? These are the basics. Hey, Nicholas, you're here early today, man. How are you? Yeah, that a boy. How did I see that? You might be wondering, if you haven't seen it in a while, about notation here, right? Remember, what do these two mean? X and Y, they are, what's the little weird looking E symbol stand for? Is a member of the set of. And then what's that little scripted R symbol? Yeah, that's the set of real numbers. So in other words, that's just a fancy way of saying X could be any number that you want. You could take the cube root of 1,000,000. You could take the cube root of -42. You could take the cube root of pi. You could take the cube root of negative square root of 2. You're taking the cube root of any number you could dream of. Okay, any real number at all. And using interval notation, that just means from -infinity to +infinity. The curvature is pointing, like there used to be this song in the 80s. I don't know, I heard it on the radio actually the other day. It was called Walk Like an Egyptian. Walk like an Egyptian. Do 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 do. As a little earworm back in the 80s. And the music video for that is that they would just be like, And I always think of this curve as being sort of like that dance move, okay? Where it's going up and to the right, it's going down and to the left, okay? And it's going to grow, even though it's growing a whole lot faster in the horizontal direction, it's still growing in the vertical direction. I could get in my little Honda Accord and I could drive, 20 miles down the road, get out, and as long as I go up high enough, I would find that curve continuing to rise a little bit more, a little bit more, a little bit more. Okay? And you can test that type of thing out by just saying, okay, what would my next perfect cube be on my list over here? If I wanted to continue with this cube root list over here, 8 is a cube root. What's the next perfect cube? Yeah, it'd be 27. Oh, shucks. You guys are supposed to scoot over. There we go. There we go. What? Come on, one note. Don't let me down. It's a great Beatles song, too. Don't let me down. There we go. All right. So, like, if I put 27 up there, or 64 up there, or 125 up there, 3, 4, 5. You can tell that it's going to start to grow a whole heck of a lot faster in the horizontal direction, going to the right a lot faster than it's going up. Well, that's okay. It's still going up. So that's why the range is all real numbers. Okay. Have you all had time to get everything on there? Now, what our goal is, if you go back up to the top of the screen here, we talked about sort of evaluating functions, talking about domain and range. But what we're going to do now is we're going to look at the graphs of various radical functions, and not just like the basic, what we would call our parent functions, but we're going to start looking at some transformations of these functions. All right. Now, there was a movie that came out probably 20 years ago by now. It wasn't a Mark Wahlberg one. It was a Shia LaBeouf. Started a movie called Transformers. You guys seen that one with Megan Fox? Okay, and it was all about like a 1980s toy / cartoon show. Y'all familiar with Transformers? I'm assuming. Okay, that's pretty culturally significant, right? And what's the idea? You remember the 18-wheeler? Who's the 18-wheeler? Optimus Prime, right? So he goes from the 18-wheeler form and then morphs or transforms into, this boss robot, and eventually I think they give him a sword even, right? And the idea of transformation is he changed from one thing to the next, okay? So when we talk about transformations of functions, Okay. What we're going to do is we're going to change what the parent function looks like. Okay. So like y equals square root of x. Now we've got y equals square root of 2x minus 1. And we're going to study, okay, what changes occurred to that function and how did they transform the parent graph? Okay. Now, if I look at y equals square root of x and y equals square root of 2x minus 1, it should be pretty obvious there's a couple of adjustments, a couple of changes that we've made here, right? What are they? What's the difference in these two red things? Call it out. There's a 2 and there's minus 1, okay? There's a multiplying by 2 and there's a subtracting by 1. And what we're going to eventually learn is things like, oh, when you multiply by a factor, you are stretching it in one direction. When you add or subtract by a term, you are shifting it in one direction or the other. And we're going to learn all about those next week, okay? But right now, I want just to simply know what is f of 5 and what is f of negative 2. Mossy, help me with f of 5. What do I do? What is f of 5 going to be as far as calculations go? How do I run those numbers? Fabulous. So 2 times 5 is 10, minus 1 is 9, and then that equals 3. So as far as an ordered pair is concerned, okay, an ordered pair for this function, we would say would be 5, comma, 3, right? That would be on the curve. That would be on whatever, and we're not asked to graph this one out, but that would be on the curve. How about f of negative 2, okay? Let's see here. Andrew, Jago, can you hear me at home? Can you make a microphone work at your house?
Yes.
All right. So what do you do for f of negative 2?
You would do 2x minus 2 would equal 0, and then it would be the square root of negative 1.
Well, we're multiplying. I want you to multiply those. Instead of 2 plus a, it's 2 times x. So in other words, if x is negative 2, what's 2 times negative 2?
Negative 4.
Subtract 1 more, and you get?
Negative 5.
Square root of negative 5. All right, class. Do a little beard stroke, beard stroke, beard stroke here. What do we think about that? Jack McBee is vigorously shaking his head. Drew Benton, you're shaking your head. Can we take the square root of a negative number? Therefore, we would say this one is undefined. Okay? Therefore, there is no point on the graph at x equals negative 2. You know? So like if I was graphing this one, I'll go ahead and let the cat out of the bag as to what this graph would look like, right? This graph right here. It's not negative 1. Shoot. Let me get my head on straight. Sorry. We plug in x equals 1. 1 is the square root of 1. We get right there. 1/2. Yeah, there we go. Okay, good. So here is what this graph would sort of look like. Okay. Is there anything going on over here in the realm of x equals negative 2? Is the curve even over there? No. That's because the domain of this function, something that we'll practice finding, again, like I said, next week, the domain of this function is from 1/2 to positive infinity. Okay? And it does not, therefore, include a number like negative 2. Okay? So you can't, with functions like this, you can't just plug in all the time whatever you want. Sometimes there are restrictions to what you can plug in. Okay? We were able to plug in x equals 5. I forget who did that one for me. Well, we were able to plug in x equals 5, and he did a good job. He said 2 times 5 minus 1 equals 9, square root of 9. I think, Mossy, you were the one that did that for me. Square root of 9 equals 3, and it was gravy. And then we tried to sit here and plug in, I think Jago tried to plug in negative 2, and it was like, well, I got a negative radicand. Sorry, doesn't happen. Okay? Hey, great job today, fellas. I want you to study a little bit. Nothing from 8.7. 8.7's new. We'll deal with that next week. But 8.1 through 8.6, have a little quiz for you guys tomorrow. You guys that are at home, you'll take it on the internet. I'll have a link for you to take it on the internet. And then you guys that are here in class, I'll probably just give you a pencil paper one. Right? be easy enough. All right, thank you so much, and I hope you all have a wonderful day. Live Jesus in our hearts forever. Okay, I'll shoot you an email with the quiz link in it. Thanks.